Hello everyone, welcome to Our Classes. This is Tushar Shaw, and in this video we will be continuing to solve the BHU PET 2020 questions that we were solving since the last 16 videos. Okay, as you can see, I have already attached the question number 17 in the screen, so it will be like easy for you to follow up. So obviously we did up till question number 16 in the last video, so we are continuing from question number 17. Okay, so basically in this video I won't be like giving you the exact representation of the examination and stuff, because this video is going to be a long one. We have to do two questions on that, so therefore we will be still skipping that part and moving on to the questions for this video. Again, in the next video we will be discussing a bit about the examination, because obviously discussing the examination helps us you to helps you to basically reconnect with the terms that are there in the examination, then follow up quickly with the questions along. Okay, so basically let us not waste our time in any of those stuffs, non-requirement stuffs, and let us dig into the questions directly, so that it will be like very important, and therefore we will be solving it very quickly. Okay, so basically the question number 17 asks that glycine on heating alone gives. Okay, so basically what is glycine? So let me just write down glycine for you. So glycine is an amino acid. Okay, what kind of the simplest amino acid which is possible? Simplest amino acid. Okay, its structure is CH2. Basically an amino acid has a structure NH2 CH R COOH. Okay, this is the structure of an amino acid. Now if R is equal to just H, nothing else, that is we have the structure like NH2 CH2 COOH. Okay, this is the simplest amino acid when R is equal to H, and this is known as glycine. Okay, so we are in the reaction that is given, we have to heat amino acid just alone heating. Okay, so let me just So let us hear, if amino acid is heated basically in obviously in alone condition, then direct cyclization with the two of them would be attached to each other via the direct addition, and the cyclization would be taking place. The mechanism is, let us say we have NH2 over here, we have CH2, we have C double bond O OH, another molecule of we have C double bond O OH, and we have CH2, and we have NH2 over here. So what would happen is, this lone pair would be attacking over here, this bond will be going up, and this lone pair will be attacking over here, this bond will be going up. Okay, so the next thing that we'll be getting is basically N. Here we will be having N. Okay, this compound, and here we'll be having O minus with OH, and here we'll be having NH2 basically plus, and here also NH2 plus, and O minus with OH. Okay, so in the next step what would happen is, this for both the sides O minus will be falling off, and OH minus would be released from the system. Okay, so minus 2 OH minus. Okay, so we will be getting NH2 plus plus, here we have double bond O and double bond O. Okay, then again 2H plus would be released from the two nitrogens that are there, so we will be getting N, we have double bond O, we have double bond O, we have NH, we have NH. Okay, so this is basically, and the two OH minus and the two H plus would be there, they will be like forming two water molecules in that case. Okay, so basically what would happen is, this structure is known as diketopiperazine. Okay, so why diketopiperazine? Because piperazine structure is like this. This is piperazine. So this is diketo derivative of that. So diketopiperazine. Okay, So basically this is the structure that will be obtained. So here the answer would be option D. Okay, option D here would be the correct answer. But one thing I would like to mention over here, that let us check out other options also and see whether why they can't be the answer. So basically zwitterion, C is equal to zwitterion. So what is a zwitterion? When the molecule itself stays in the ionic form, that which is because of the acid base formation. Okay, this group is an amino acid. Basically it has an amine group which is basic and acid group which is acidic. Okay, so the zwitterion is basically the stabilization of the acidity and the basicity by exchange of protons and lone pairs. Okay, so glycine, when glycine is in normal state, it will remain in the zwitterionic form itself only. Okay, we assume that the zwitterionic form is the normal state, and basically the glycine stays in this form only because this is more stable than the normal structure. Okay, now 2-amino ethanol. So 2-amino ethanol basically is NH2 CH CH2 OH. Is this possible from this? Yeah, this can be possible from this one if we had reduced glycine. Okay, if we had reduced glycine, then 2-amino ethanol would have been formed. Okay, and methylamine basically MENH2, which means that this CO2H would should have been fallen off, should have been released. But in that case, you need to have COONA. If we had like the derivative known as let us say NH2 CH2 COONA. If that was a derivative, then on heat, then on giving NaOH, CaO and heat, CO2 would have been released from the system, giving us methylamine as the major product. Okay, but that is not the case also. So here option D would be the correct option. Just note that down. Okay, moving on to the next question. Basically this was a short question, so we'll be incorporating one other question also. So this is a very big organic question, so let us look into that. So the major product in the hydrolysis of neopentyl bromide is, okay. So what is neopentyl bromide? So let me just firstly write down the structure of neopentyl bromide. Let me just change the color. Okay, so neopentyl bromide is basically this one: CH3, C, CH2, Br, CH3, and CH2. Okay, so we are doing a normal hydrolysis, which we are passing H3O plus in the system. Okay, so first of all, what would happen is this Br would be, as this is an SN1 mechanism. Okay, this one would follow an SN1 mechanism, and this Br minus would be released from the system initially. Okay, so we will be having this carbocation and CH3. Okay, now this is a 1D carbocation. Okay, so what would happen is with this 1 degree carbocation, rearrangement would take place. That is 1,2-methyl shift would take place. Okay, so this bond would be directly with the electrons would be going over there. So 1,2-methyl shift would take place. So we will be getting CH3, CH2, CH3. Okay, now and here we is a plus. Okay, now this one is a 3-degree carbocation. Okay, so basically you can see that obviously this 3-degree carbocation is way more stable than the 1-degree carbocation over here. Okay, that is because of the fact there are 3 plus I effects in this one, and here it is only 1 plus I effect. Though it is a tertiary butyl group, plus I effect is very huge, but not comparison to the 3-degree carbocation. Okay, so that is why it is more stable over here. The now hydrolysis here would be like, if we are talking about SN1 mechanism, then H2O would be attacking over the control of H2O would be attacking the carbocation. We will be getting this kind of product: CH3, C, CH3, CH2, CH3. We have OH2 plus, and again if we release one H3O plus from the system, then we will be getting CH3, C, CH3, OH, CH3, CH2, and CH3. Okay, so basically this is the product that will be obtained. This H plus is again and obviously when HBr is also released, Br minus is from here and H plus is from here. Okay, so yeah, so HBr is formed obviously. So basically you can now compare which one is the correct option. So they, a normal student who does not know the reaction mechanism in a certain way, they would attach the OH in the 1 degree carbocation only, giving us the B product, which is exactly wrong, which is totally wrong, and we should not do it. Okay. Now, this answer and this answer is also not possible by any means, because however be the mechanism, you cannot bring option A and option D any. If you bring it, you are not eligible for studying the organic chemistry, because in that way, in no other way possible, you can bring A and D even after doing a mistake also. Okay. In no way it is possible mechanistically. So option C is what we have obtained in the as a product with HBr as the byproduct. So option C here would be the correct option. Okay. So this was all about this video. I hope you have learned a lot about the hydrolysis of neopentyl bromide, which is basically how migration and the 1,3 methyl shift occurs, and the heating of glycine would be giving us what product, and the other options how they are found basically. So that was all about this video. So we'll be ending the video here. Question number 18 has been done. So from next video onwards, we'll be starting from question number 19. Okay. So thank you guys for this video. I'll see you guys in the next one.